Okay, so this first part is solving equations which we've already factored and which are already equal to 0. So you can see that this equation here, it's equal to 0, definitely. It's already equal to 0. And it's already been factored. And the factors are x plus 3, this is one of them, and x minus 5. Right? Remember when we would factor like quadratic trinomials, we would get stuff that looks like this. Okay, if it's already factored and equal to 0, it's a very easy problem. And that's all that you're going to have to be asked to teach them when they come back. I know that this is x plus 3, that factor, times x minus 5, this factor, equals 0. So using that same property that we just talked about, that tells me that either this factor, x plus 3, has to be 0, or this factor, x minus 5, has to be 0, or they both have to be 0. So the way I find the solutions are, I set each factor equal to 0 and solve. So I'm going to end up with two equations. So let me show you what I mean. I take this factor, x plus 3, and I want to know what makes x plus 3 be equal to 0. What value of x would do that? So the way I find that is I set it equal to 0. And I want to know what would make this factor be 0, so I'm going to set x minus 5 equal to 0 as well. And then these equations are real easy to solve. What do I do on the first one? Minus 3. Good, Chris. And so I get x equals negative 3. And what do I do on this one?
Add 5.
Add 5. Good. And so I get x equals 5. Those are my solutions. X equals negative 3 and x equals 5. That's it. That's all the work on these. Of course, it's going to get slightly harder later, but for these first problems, the one that you're asked to teach, that's it. That's the whole problem. And we can confirm that this is true. Because what I'm claiming, when I put a box around this and say this is the answer to this problem, is I'm claiming if I plug in negative 3 into this problem, that I get a true statement, right? That these will multiply to be 0 if I plug in negative 3. And I'm also saying if I plug in 5, these will multiply to be 0. So let me just prove to you real quick that what I'm saying is true actually is true. So if I plugged in negative 3, I would have negative 3 plus 3 times, negative 3 minus 5 equals 0. And let's see if we get a true statement when we work this out. What's negative 3 plus 3? 0. So this parentheses is 0. And negative 3 minus 5? Negative 8. Good, Alex. What's 0 times negative 8? So I end up with 0 equals 0. That's a true statement. That means this is a solution, right? This makes it true. Let's try it with 5. So if I plugged in 5, I'd have 5 plus 3 times 5 minus 5 equals 0. Well, 5 plus 3, that's easy. What's that? 8. And 5 minus 5?
0.
And 8 times 0 is 0. So this one works too. Those are the only two numbers that you can plug in that make a true statement. I'm going to work a couple more examples before I bring them back, but are there questions about this first one that I've worked?
Can you leave it on board?
Sure. Just tell me when you're done. This is pretty self-explanatory, right? You got it? Okay.
Question.
Yes, sir.
On that equation you just worked,
Yes.
is that a negative 3 plus 3 or 5
Where are we looking at?
at the top?
Here or here?
There.
This is negative 3 plus 3, and this is negative 3 minus 5.
Okay. Alright.
You got it? All right, so let's work a couple more. Oh, I guess I forgot to erase this earlier. Okay, so on this problem, it's already factored, because I have parentheses times parentheses, and it's already set equal to 0. So that's going to be really easy to solve. I know if this parentheses times this parentheses equals 0, then one of these parentheses has got to be 0. So let's figure out what values of p would make each parentheses equal 0. So we'd set p minus 8 equal to 0, and I'll solve that in a second. That'll give me one answer. And then if I set the other parentheses equal to 0, I'll get the other answer, right? So these are easy. So I'll tell you what, I'm gonna call on some people. Nathan, how do I solve this? Add 8. So what's the solution to this one? P equals 8. Good. So that's one of my answers. Okay, now I just got to find the other one. Swayze, what would I do first on the other one?
Subtract 7.
Okay. And I get 2p equals negative 7. And then what's the last step, Swayze?
5 by 2.
Good. And since 2 doesn't go evenly into 7, that one's just going to be a fraction, right? So p equals negative 7 over 2. And that's it. Those are the two things that make this a true statement. The two solutions. So in reality, not only are these solutions to this equation, but these are actually also the x-intercepts of this function. And we'll look into that a little later. If we actually graphed it, you'd see it crosses the x-axis at 8 and at negative 7 over 2, right? Negative 3.5. Questions about that one before I work the next one? No? Okay, either this has got to be 0 or this has got to be 0. So we set up our two equations. And we solve them. Listen, what do I need to do first to solve this one? Good. And so I get 3x equals negative 4. And then what do I do? Divide by 3. And since 3 doesn't go evenly into negative 4, this answer is a fraction. Okay, there's one of them. Bella, what do I do here? Well, I'm already subtracting it. Add it, good. And so I get 6x equals 5, and then what? Good. And this one's a fraction too, right? So x equals 5 over 6. That's it. That's all I want you to show them. Does everybody feel like they're in a place where they can explain that when they come back in? Okay. No questions? Awesome. We'll bring them back.